Hey there, my name is Ron Pereira of Gemba Academy, and I'd like to welcome you to this course that's focused on dealing with the 7 deadly wastes. Now, in this first module, we're going to get things started with an overview of the topic, where we'll learn what the 7 wastes are, allowing us to then build on this knowledge in later modules, where our focus will be on finding ways of eliminating all forms of waste. Well, specifically, by the end of this module, you'll know exactly what it means for an activity to be value-added, non-value-added, or waste. And you'll also be able to identify what are commonly referred to as the 7 deadly wastes. Now, throughout this course on the 7 wastes, we'll be visiting RAM Technologies, a custom foam fabricator located in Washington. And while inside their factory, we'll do our best to demonstrate what each of the 7 wastes look like, while also showing what things look like when these wastes are eliminated. But let's go ahead and start things off by discussing the various elements of work. Now, when I say elements, I mean that any work or activity we do can be classified into one of 3 categories. First, we have what we call value-added work. Now, for something to be called value-added, 3 things must exist. The customer must be willing to pay for it. The thing must be changed in some way. In other words, we like to say that when value-added work is done, the form, fit, or function of a thing is changed. And finally, the work must be done right the first time. Now, if any of these 3 points are missing, the step or process cannot be said to be value-added. And while value-added activities are what we prefer to do most of the time, we won't spend much time or effort focusing on value-added steps as it relates to reducing waste. But I'll explain why this is later in the module. Next, non-value-added work is work that adds no value but must be done to meet the customer's needs under today's conditions. Now, this is a minor area of focus in lean manufacturing since it's harder to improve in this area and there's less of this type of work than the third and final category, which is waste. Waste is also referred to as muda, which adds no value and customers are not willing to pay for it. Now, the best way to understand the impact of waste is to look at work from the customer's viewpoint while asking yourself, would I want to pay for this if I was a customer? Now, even some things that you would be willing to pay for may be done at a cost that's too high or with too many non-essential steps. Now, it could be said that eliminating waste is like defragging a computer. When you defragment a computer, you will rearrange the data so that you can open up space. And when data is fragmented, there are useless bits that are filling up memory, much like the useless amounts of waste taking up space and time within our processes. By identifying where value-added portions are and moving or removing the non-value-added bits, you improve performance of your computer. In the same way, taking waste out of your process improves its performance by radically reducing the time it takes to fulfill a customer request. Now, as we discussed earlier, we'd prefer to spend most of our time doing value-added work. Unfortunately, when we look at the total lead time through a value stream, we find that a massive amount of muda, or waste, is stealing resources and time. Another unfortunate activity we often see companies doing is attempting to reduce the overall lead time by making the value-added processes more efficient. In other words, as an example, they work to save a few seconds or minutes of machine cycle time in order to reduce the overall lead time. And while this isn't necessarily bad, there's far more opportunity in reducing the waste in the process first before worrying about improving the value-added steps. With all of this said, in order to be able to attack this waste, we must be able to identify it. So, let's spend the remainder of this module by discussing what we refer to as the 7 deadly wastes. Now, the first waste is defects, which is simply work that is less than the level the customer, both internal and external, has requested. Now, some examples of defects are rework, scrap, missing parts, wrong parts, and yield loss at startup. Now, as a point of reference, the waste of defects is also sometimes referred to as a waste of correction. Now, in this example, we see that our operator, whose name is Isaac, is struggling to understand his work instructions, and as such, scrap parts have resulted. Next, we come to the waste of inventory, which is any work or material on hand other than what's needed right now to satisfy customer demand. Now, some examples of inventory waste are excess raw materials, work in process, finished goods, supplies, and spare parts. Now, in an upcoming module, we'll spend more time exploring the different types of inventory we might have on hand, such as cycle stock, buffer stock, and safety stock. Now, in this example, we see Isaac surrounded by piles of inventory, making it hard for him to even know what to grab. All right, next we experience the waste of processing, sometimes called over-processing, which is when something's designed in such a way that uses more resources such as space, energy, or people than is truly required. Sort of like using a sledgehammer to smash a peanut. The waste of processing is definitely the hardest to understand and learn to see, since the most common root causes are a lack of understanding of customer needs. Now, some examples of processing waste are machines that are slower or faster than needed, equipment that uses more energy than needed, redundant work such as copying information, drilling a hole instead of punching it, and cleaning something multiple times. Well, here we see Isaac carefully measuring each piece of foam when, as it turns out, these pieces have already been cut to size and don't require such meticulous and time-consuming verification. Next, anytime there's idle time created because materials, machines, or information are not ready for people, we have the waste of waiting. Now, this waste is usually less visible than the others because it's often replaced by overproduction or busy work. So, in fact, when waiting becomes visible, it's important to keep people from working just to keep busy, since this busy work often does more harm than good. Now, some examples of waiting are people waiting for materials, an accountant waiting for information to close the monthly books, warehouse employees waiting on a forklift, or a nurse waiting on important supplies to arrive. Now, in this scene, it seems that Isaac has run out of work and is obviously looking for something to do, so he resorts to his newspaper and text messaging his friends. Okay, well, any movement of people that doesn't add value to the product creates the waste of motion. And by nature, most motion is in fact wasted. Consequently, by closely studying motion and the time it takes to do a task, it's often possible to improve the manual operation times by 30 to 50%. In addition, eliminating motion waste is a key part of reducing changeover times. Now, some examples of motion are walking, reaching, searching, lifting, choosing, arranging, and turning. Now here we see Isaac taking several extra steps in order to reach his air nozzle. He's also wasting motion as he has to take a step to his right to inspect and place the finished part on the table. Now, the next waste, which is often confused with the waste of motion, is transportation, which is the movement of materials that adds no value to the product. Another way of saying it is transportation is the movement of materials using carts, trucks, forklifts, or simply your arms and legs. Now, it should be said that while moving product on a conveyor is not as bad as moving material from one disconnected process to another, it's still conveyance, a type of transportation waste, since conveyors are inflexible and require space and energy. Now, some examples of transportation waste are moving finished goods to storage, moving work in process to the next step, moving between functional areas, moving parts to the line, and moving items to quality assurance. Or, as we see here, Isaac is forced to leave his workstation in order to transport some shrink wrap from across the plant to his workstation, which obviously takes him away from adding value to the product he's working on. Finally, but most certainly not least, we come to what lean practitioners commonly refer to as the mother of all wastes, overproduction, which occurs when we make more products than the customer needs right now. Now, the reason we say overproduction is the mother of all waste is because it often leads to all the other wastes in one form or another. For example, overproduction multiplies the other wastes such as inventory and covers up problems such as waiting or variability in demand. And it makes it harder to understand our true capacity. Now, some examples of overproduction are making extra parts to cover for scrap, forecast production, economic order quantity lot sizes, piece rate production, and production done simply to maximize utilization or absorption. Now in this final scene, Isaac's internal customer only needs one box of work in process, but since he's fallen into a bit of a groove, Isaac decides to produce a few more parts even though they don't even fit inside the box. And that's the 7 wastes. Now, in the future modules, we'll visit with Isaac again as we work to eliminate, or at least improve, each of the wasteful situations we witnessed in this module. But in our next module, we're going to cover one of the most powerful methods available to be able to quickly spot each of these wastes in your office or factory floor. And as it turns out, this particular technique we'll be teaching was popularized by Taiichi Ohno, one of the chief architects of the Toyota production system many years ago. So, we'll speak to you soon.